standard vector-only RAG frequently hallucinates on enterprise queries, and it's not the LLM's fault. The real culprit is chunking. Slicing documents into tiny pieces rips apart the long-range dependencies every business process relies on. Support bots give incorrect troubleshooting steps, product catalogs mix incompatible part numbers, and HR tools fabricate policies by mashing together unrelated paragraphs. Companies are burning millions on hallucinated answers that erode user trust. You're about to see exactly how a private knowledge graph stops the lies cold. This is the classic RAG flow. A user query gets embedded, the vector database, think Pinecone or Milvis, returns the top K most similar text chunks. Those chunks are stuffed into a system prompt, and the LLM generates an answer. The entire system lives and dies by that chunk selection step. Even with re-rankers, the model still sees isolated fragments. If the answer requires connecting a warning on page 2 with a root cause on page 47, vector similarity alone will miss it every time. These aren't edge cases, they happen all the time. First, a maintenance chatbot misses the relationship between a warning slug and the error timestamp because chunking split them apart. Second, a product support assistant confidently tells a customer to mix parts from incompatible SKUs that happen to land in the same top 5 chunks. Third, an internal HR bot pieces together remote work eligibility and overtime pay from 2 different handbook sections and invents a policy that never existed. In every case, the LLM sounds fluent and dead wrong. Picture a 200-page service manual split into 512 token chunks. Chunk A describes a symptom. Unit fails to spin up. Chunk C, 40 pages later, holds the root cause, a faulty capacitor on revision 2 boards. A technician's question spans both fragments, but vector search only grabs A because it matches the symptom keywords. The causal link between A and C is invisible to the machine. That's the semantic gap. You've lost the document hierarchy, the cross-reference structure, and the very logic that makes the answer correct. The fix is 2 words: knowledge graph. Instead of storing floating text chunks, you store entities, customers, contracts, service tickets, product parts, and the explicit relationships between them. When you query a graph, you retrieve a connected subgraph, not a handful of isolated sentences. That subgraph preserves context, eliminates the hallucination triggers we just saw, and scales across data silos without anyone having to predefine every possible question. The best part? Tools like Microsoft's GraphRag library do the heavy lifting, making it accessible even for teams without a dedicated graph engineer. Think of a graph as a map of your enterprise. Nodes are the real-world things: customer, contract, service ticket, part. Edges are the verbs that connect them: purchased, generated, contains. Now, a multi-hop question like, which customers bought a part under a contract that has an active service ticket, becomes a simple graph traversal, not a keyword guessing game. You'd need a spreadsheet jockey and 3 browser tabs to answer that manually. The graph answers it in milliseconds with perfect recall. Side by side, the difference is stark. Vector-only RAG retrieves disconnected chunks. Your answer is a collage of maybe relevant sound bites. GraphRag pulls a connected subgraph where every entity's role is explicit. So a question like, which customers were affected by the faulty pump batch shipped in October, literally walks the path, part batch shipment customer. That's multi-hop reasoning the vector engine cannot fake, no matter how many re-rankers you add. GraphRag reliably answers those queries with high confidence, cutting hallucination events dramatically. A private knowledge graph doesn't build itself. You need to close the semantic gap with 4 concrete bridges. First, map your real databases, Salesforce, SAP, Jira, to an ontology. Second, reconcile entity names so client and customer point to the same node. Third, capture structure that's invisible to a vector index, like the chapter step hierarchy inside a PDF manual. Fourth, bake in domain rules as constraints to stop the graph from ever returning impossible answers. Each bridge makes the difference between a demo that looks good and an enterprise system that actually works. Here's what that first bridge looks like in practice. You've got Salesforce tables, account, contact, opportunity, living behind your firewall. Using an open-source tool like OnTop and the W3C R2RML standard, you write declarative mappings that convert each account. Name into a customer node, each contact into a person node, and each opportunity into a deal node with relationships intact. The raw data never leaves your VPC. You're just creating a virtual, queryable graph layer that sits on top of your existing databases. 5 graph databases that let you deploy a private knowledge graph without sending data to a public API. Neo4j is the easiest starting point. Cypher reads like natural language. Amazon Neptune gives you a fully managed Sparkle endpoint if you're already inside AWS. Stardog adds reasoning and virtual graphs, so you don't have to physically migrate everything. Flurry provides built-in data provenance and version control, so you can track every change without a separate audit system. And Databricks users can tap Unity Catalog plus Spark GraphX for massive scale graph processing. Pro tip: prototype entirely in Neo4j Aura DS's free tier. No credit card, and it runs inside your own VPC so nothing leaves your control. This is the fastest way to get a private knowledge graph up and running. Sign up for Neo4j Aura DB free. No local install, no credit card. Create a free instance, name it something like Private KG Demo, and open the built-in Neo4j browser. Then run a single Cypher query. Create a product node, relay, that has an issue, voltage spike. Bam! You've got a live graph you can traverse with match queries in under 10 minutes. It's all private, fully hosted in your region, and the free tier is enough to prototype your first enterprise KG. RDF triples capture facts as 3-part statements: subject, predicate, object. In this neon diagram, a relay has failure over voltage. That's it. No fuzzy similarity, no vectors guessing relay failure event sounds like motor overload. This machine-readable precision lets you run Sparkle queries across federated private graphs, and every relationship is auditable because the data never leaves your enclave. Here's the killer feature. A triple store enforces cryptographic correctness. A fact either exists as a triple or it doesn't. Your graph shrugs like a teenager asked to do chores. No fuzzy similarity, no close enough answer. When the compliance officer asks which servers were patched on March 1, a knowledge graph traverses exact relationships and returns the exact list, never guessing from vector proximity. That's the difference between a trusted audit and a regulatory nightmare. You can deploy a private knowledge graph entirely on-premises or inside your VPC. Tools like Flurry or a Neo4j cluster sit inside your firewall, meaning all context enrichment stays within the enclave. No external API calls for retrieval, no third-party model touching your raw data. That's how you maintain HIPAA, GDPR, and ITAR compliance while still getting powerful contextual AI. Your data never takes a field trip to a public cloud. This is the complete private KG RAG architecture. Raw data sources, SQL databases, PDFs, logs, flow into Apache Tika for schema extraction. OnTop maps those schemas to an ontology, then we construct the graph and load it into a private graph database like Neo4j or a triple store. The retrieval engine uses deterministic graph traversal with an optional vector fallback only when needed, and finally the LLM generates a grounded answer. The beautiful part? Every single component can run inside your private cloud with no data exfiltration. Take a real enterprise support scenario. List all unresolved tickets for customers with active SLAs in Europe. A knowledge graph RAG traverses the graph and answers with near 100% precision. Meanwhile, a standard chunk-based RAG often fails to connect the dots. Relevant entities scattered across chunks, and vector proximity guesses wrong. Across 5 key metrics: accuracy, multi-hop success, hallucination rate, freshness, and auditability, the graph approach dominates. This isn't theory. Industry observations from Microsoft, GraphRag, and Databricks deployments confirm the trend. You can build a private knowledge graph from your own PDF manuals in 4 code steps. Step 1. Use PyMU PDF to extract text and tables. Step 2. Run Spacey's named entity recognition to pull out products, parts, and failures. Step 3. Map those entities into triples with simple rules. For example, product X has part Y. Step 4. Shove everything into Neo4j using the Python driver. We'll give you a copy-paste notebook that does this for a sample motor manual, so you can have your first industrial KG running this afternoon. But here's the part. Almost everyone gets wrong. Dumping your data into a graph without an ontology turns it into a messy vector store wearing graph clothes. On the left, an ad hoc graph with labels like relay failure and failure event, 3 different names for the same concept. It hallucinates just like vector search. On the right, an ontology-driven graph with a single failure event class, defined properties and constraints. The right side eliminates the semantic gap. Queries are deterministic, answers are exact. Don't skip the ontology. It's the difference between a graph that actually works and one that just looks fancy. You can build a production-grade ontology in 5 steps with Protégé, a free desktop tool. 1. Sit with domain experts and list core concepts, things like equipment, failure, and maintenance task. 2. Create a class hierarchy in Protégé, like equipment subclass turbine subclass blade. 3. Define object properties that connect concepts. Has part, causes, resolved by. 4. Add data properties that carry actual values, like serial number as a string or install date as a date. 5. Write Sparkle queries to validate that the model answers real questions correctly, then export the whole thing as RDF XML. You now have a portable, private ontology that works in any triple store. If you're getting into ontology modeling, here's the tool grid that matter. Protégé is widely recognized as a free starting point for learning ADUL and RDF. WebValuel gives you a clean visual, which is priceless when you need to explain your model to the CTO. TopBraid Composer brings enterprise muscle with SheCL constraints and full governance. And Pool Party excels at taxonomy auto-tagging. Start with Protégé, get comfortable with the concepts, and then move to TopBraid when you're ready for production-grade semantic integrity. Take a single Salesforce row, account ID, industry, annual revenue. Map those flat columns to an ontology. Industry becomes has industry. Account ID becomes account ID. The result is a set of semantic triples that tell the LLM this account is a manufacturer, not just a bag of keywords. Tools like Protégé let you define these mapping rules once and reuse them across every data source in your enterprise. No vector similarity roulette. The exact cipher. Match P product, name, X, about, T, ticket, priority, high, status, open, raised by, C, customer, return, C, name. The engine walks the graph and hands the LLM only those 3 customers. Zero hallucination because every fact is a real edge, not a chunk that looks close. Baseline vector RAG often delivers low factual accuracy on complex enterprise queries. Fine-tuning helps, but adding a structured knowledge graph yields significant gains, as Microsoft GraphRag and Flurry reports confirm. Layering a domain ontology pushes accuracy even higher, often approaching production-grade reliability. That jump isn't magic. It's the difference between retrieve similar text and retrieve actual business logic. But here's the part. Almost everyone gets wrong. You can't just build a private knowledge graph, eyeball a few answers, and call it production ready. GraphRag Bench, an open-source framework by Xiang et al., measures multi-hop reasoning, entity linking, and factual consistency. Run it against your graph today. Download from GitHub and add it to your deployment pipeline. In regulated industries like medical devices or aviation, this is the step that keeps you from shipping dangerous hallucinations to the boardroom. Here's the Databricks workflow that takes you from raw logs to a governed GraphRag agent. Step 1. Ingest service logs and build the knowledge graph with Spark GraphX. Step 2. Package the retrieval logic as an ML flow model and register it in Unity Catalog for full lineage and access control. Step 3. Deploy the model to a serving endpoint using AgentBricks custom agents. This gives you a managed, secure environment. Finally, launch the Review App Chat UI so your team can interrogate the private graph without touching any raw data. Privacy isn't an afterthought when you're feeding enterprise data into an LLM. Before any prompt touches a node, replace all PII with random UUIDs, a one-liner in Python using uuid.uuid4. In Neo4j, encrypt sensitive properties at rest and tag every node with a classification label so your retrieval filters can exclude .confidential data from external-facing prompts. Data sovereignty stays intact, and you can still enrich relationships without exposing raw values. Most enterprise RAG pipelines ignore everything that isn't text. That's a massive gap. Route a scanned engineering schematic through Azure AI Document Intelligence. It performs OCR to extract text and layout, then combine it with custom extraction logic to pull out component IDs and connections. Map those extracted entities into your existing ontology and link them to maintenance specs. Even a partial multimodal bridge lets the agent answer, "Show me every panel related to Relay R7s" without a human having to flip through PDFs. On paper, vector databases look cheaper per month. But when the graph prevents a single batch of incorrect Tier 1 support escalations, the savings can exceed 10 times the infrastructure cost difference. The accuracy lift from GraphRag isn't a nice-to-have. It's the line between a maintenance headache and a self-healing support system. Always check current pricing, but in every deployment we've seen, the graph pays for itself the first time it stops a hallucinated answer from reaching production. Copy-paste recipe. Grab your support ticket CSV, load it with pandas, and pull out the entities you care about: customer names, issue types, product codes, with a few regex patterns. Build a network X digraph. Add the relationships, then push everything to Neo4j with py2neo in under 50 lines of Python. The payoff: a one-line cipher query that instantly surfaces every customer drowning in critical tickets. No dashboard required. LangChain's Graph Cipher QA chain makes this dead simple. The user asks a question, the LLM, given the graph schema, writes a precise cipher query. That query runs directly on Neo4j, returning a subgraph of facts. The LLM never sees the raw chunks. It only receives the exact triples it needs to compose an answer. Every statement in the final response can be traced back to a node or edge that actually exists in your data. No knowledge graph is perfect. Sometimes a cipher query returns zilch because relationships haven't been loaded yet or the entity just isn't there. A pure graph pipeline breaks at that point. The fix is a hybrid fallback. Try the graph first, and if you get nothing, embed the user's question with the same model you used for node embeddings. Hit a vector index to find the nearest semantic neighbors, then validate those neighbors against the graph. That way, you never dump an empty context into the LLM, and you still anchor every answer in structured facts. One line of code to catch the empty result. One line to run the vector search, and your RAG system keeps humming. You can't fix what you don't measure. Spin up a Grafana dashboard with Neo4j's Prometheus metrics exporter and pin these 3 numbers front and center. First, node and relationship count drift. A 5% drop usually means your ETL pipeline is silently broken. Second, P95 query latency. If it creeps above 200 milliseconds, your graph is being strangled. Third, freshness. Track the lag between your source system and the graph. In a support chatbot, even a 1-hour delay can recommend a decommissioned part. That's the kind of thing that gets you laughed out of a production meeting. A private knowledge graph isn't a free-for-all. Neo4j Enterprise lets you enforce access at the property and relationship level, so a support engineer can traverse, has ticket, but never has salary or any node tagged Pi. Plumb that into Microsoft Entra ID via SAML, and group memberships automatically scope what a user can see. Not a single cipher query, no matter how cleverly written, can retrieve data the user shouldn't have. That's data sovereignty you don't have to pray for. When your private KG outgrows a single instance, you don't want a monolithic mess. Neo4j Fabric lets you shard by department. Engineering lives on one shard, finance on another, while a federation layer preserves cross-department relationships. A query can start in engineering, hop through a shared supplier node, and pull cost data from finance, all without ever shipping raw PII across shards. The cluster sees one logical graph. Your compliance team sees isolated data silos. Everybody wins. A sluggish graph is worse than no graph. Users will abandon your tool before the answer appears. Start with the basics. A missing index on a node label can cost you seconds per query. Adding one drops it to single-digit milliseconds. Then profile every query with Neo4j's built-in profile command. It'll show you exactly where the database is burning time. Batching writes with unwind and tuning the page cache are the difference between a graph that purrs and one that gets P95 latencies measured in heartbeats. An LLM doesn't know cipher unless you teach it. Give the model a system prompt with a handful of real examples from your domain. No tutorial docs, just actual question-to-query pairs. Then lock it down. Only match and return are allowed. Any delete or set gets blocked by wrapping the generated text in explain before execution. It's a remarkably simple guardrail, and in practice it drastically reduces hallucinated queries by preventing destructive commands and forcing the model to explain its intent. That's the difference between a bot that occasionally drops a table and one that's safe enough to point at production. You've got 3 solid picks for turning natural language into cipher. LangChain's Graph Cipher QA chain is the easy button. Feed it your schema and a question, it returns a query. For monster schemas where context windows choke, the Neo4j GenAI plugin smartly retrieves the relevant schema bits via vectors. And if you want the absolute highest accuracy, fine-tune something like Code Llama on your own graph's question cipher pairs. But budget a week for data prep and training. Pick the tool that matches your tolerance for tinkering. If your private KG must align with strict regulatory ontologies like HIPAA or international drug classifications, an RDF triple store with ABL reasoning is the right choice. SparkQL's steep, but it's precise. For the vast majority of enterprise use cases, a property graph like Neo4j wins on speed, flexibility, and developer ergonomics. You don't need a PhD in semantics to model an IT asset graph. Choose RDF when the compliance rulebook demands it. For all other scenarios, property graphs are the faster, more practical path. There's no gray area here. If your knowledge graph will contain personal data governed by GDPR, health records under HIPAA, proprietary engineering designs, or anything covered by ITAR, the graph stays behind your firewall. Full stop. Not just the raw text. Even the embedding vectors can leak sensitive structure, so don't ship them to a third-party API. Deploy your embedding model locally, run the graph on-prem or in a locked-down VPC, and treat every external call as a potential data breach. Here's a real-world facepalm. A support chatbot started recommending a part that had been end-of-life for 6 months. Why? Because nobody updated the knowledge graph after the product lifecycle change. That's graph rot. And it turns your RAG system into a hallucination machine. The fix is brutally simple. A weekly refresh job that reads from your live ERP, stamps a last updated timestamp on every entity, and automatically purges anything that outlives its business rule. Stale data isn't just messy, it's actively dangerous. Secure your knowledge graph with SSO. Configure Neo4j to use Microsoft Entra ID SAML. That's the renamed Azure AD, or Okta. Map group memberships to scopes. Read-only for analysts, full access for admins. This enterprise-grade step slams the door on unauthorized data exfiltration through LLM queries. You can complete the integration this week with your existing identity provider. When a RAG hallucinates a maintenance instruction, it can shut down a factory floor costing $100,000 an hour, or trigger a compliance fine that runs into 6 figures. Private KG RAG is an insurance policy that pays for itself the first time it prevents an incident. Start with a freshness audit on your graph relationships this sprint. It's the fastest way to surface stale data before it causes a catastrophe. Watch this graph expand autonomously as an AI agent ingests real-time sensor data, creates new nodes, and queries the graph to proactively alert operators. This is the promise of agentic graph RAG, a system that self-enriches its ontology and closes the loop on data drift. It's not science fiction. Pilot projects are already running at major manufacturers. Prepare your architecture with event-driven ingestion jobs to stay ahead. Follow this blueprint to ship a production-ready private KG RAG. Start by cataloging every data silo and its schema, then model a domain ontology in Protégé. Next, ingest the data, then wire retrieval into LangChain. After launch, monitor accuracy, data freshness, and access controls continuously. Download the free IT career roadmap linked in the description. It maps out the skills that get you hired in AI ops, including graph RAG, cloud architecture, and automation. No gatekeeping, just your next career move.